Morning, everybody. Today, we're going to be talking a little bit about TLS certificates. What a fun topic every single day. I see people on Slack, why is this not working? Because your certificate name is localhost and you're connecting to somewhere else. So let's not do that. So this is me. I introduced myself yesterday, so I'll just skip over this. But those are my social media stuff. So TLS, why do we use TLS? What is it good for? TLS has three very important guarantees. The first one is confidentiality, and that it guarantees that your data is not being read on the wire. The second one is integrity. It guarantees that somebody's not going to modify your data as it's being transported from a client to a server or whatever. And the third one is authenticity. And this one guarantees that you're connecting to who you're actually intending to connect to. And I put an asterisk here because this one is very hard with self-signed certificates. This is why we have certificate authorities. We have a trusted third party that signs all the certificates we use. And that's why we have the green check mark in the browser and so on. And most of us have used something like DigiCert or Kamado or any of these. And they're all very painful to experience because all of them require manual interaction. You go to some website once a year, once every 3 years. Don't do that. And you go through this whole process of like creating a CSR and signing, getting it signed and replacing it. So we're at a DevOps conference. We want to automate all this stuff. Well, now we can. There is a better option now, and this is the Automatic Certificate Management Environment, or ACME. And this is an official protocol. There's an RFC out there. It's a standard that we can all use. And this is what Let's Encrypt uses. There's actually a Go project that's open source if you wanted to become an ACME provider. Let's Encrypt is currently the most popular one, the only one. But given its popularity, there will probably be more. So yeah, let's look at how ACME does this. So ACME requires that for you to obtain or renew a certificate, the client that you are using has to solve a specific challenge. And understanding these challenges will help us if we are using a tool to get certificates from Let's Encrypt. It'll help you debug issues. So I want to cover these. So what are the challenges for? They're for proving that you own the domain that you want to get the certificate for. And if you've ever added a new domain to Google web host, you will also be solving a challenge there. Maybe it's a text record in DNS or something like that. So these are kind of similar. So let's look at them. The first one is an HTTP challenge. Basically, the Let's Encrypt CA will make a GET request to some domain on port 80, and it will have some random URI, and the server will have to respond on that URI. And that's how you solve that challenge. So for that, the domain, obviously, you must own it, and it must be reachable, and port 80 has to be open. And with that, you can get a valid certificate. Second one is TLS SNI. It's exactly the same, except instead of reaching to a URI, it will do the CA will do a TLS handshake, and it will use a custom server name as the challenge. And this is the one that I use in most of my open source projects. MicroMDM does this. I have a few other server projects that automatically fetch certificates. They will ask you to have port 443 open, and it'll automatically fetch and renew certificates. And then finally, this one is actually a really cool challenge that I use a lot at work, and that's the DNS challenge. it's nice because it does not require you to have any open ports. But it does require you that you use a DNS server that has some sort of API. So popular ones are a G-Cloud one or the Route 53, Cloudflare, DigitalOcean. They all support this in the tools that I use. And the CA automatically creates a text record, well, asks your client to create a text record. You can do it manually, but obviously we want to automate this so you don't. One thing very important to know is rate limits. Let's Encrypt is a new service. It's been around for a while. It's great. But there's one gotcha that you can only get, if you have subdomains, you can only have 20 certificates per week for a domain. And if you're not careful with your automation, or if you have lots of subdomains, you're going to get locked out for a whole week. And that is not fun. I've done that once or twice with our main domain, and I just had to wait. And developers were like, why can't I spin stuff up? Well, because, I don't know, because just wait. So yeah, there is a way around it, and that is they allow you to create something called a certificate bundle. You can have, in the subject alternative name, you can put all the domains you want. You can put up to 100 per certificate, and then you can still have 20 certificates. So that gives you 2,000 possible domains per week. But you have to plan ahead for things like that. So let's look at some tools really quickly that you can start using today that are very practical. My favorite one is Lego. And it's an open source thing. Lego, I use it a lot for the DNS challenge. This is how it works. If on Route 53, I export some environment variables for connecting to Route 53, and then I run the Lego command, and it asks me for my email, and it asks me for these domains that I want. It can be 1 or it can be up to 100. And then I put the DNS provider, I accept the terms of service, I run, I get back a certificate. It solves all those challenges. Very similar with G-Cloud or Cloudflare or so on. You just have whatever it requires you to authenticate to that API, and then Lego solves all of that. So another very popular tool is Caddy, which is an open source server. And Caddy, it has a lot of really nice features. The main one being that it'll use any of these methods to obtain and renew certificates, and you don't have to worry about it. You can use this as a proxy. Graham Gilbert wrote a really nice blog post of how you can use Caddy as a Mac admin. I recommend you check it out. So, do you need a server for Monkey? Who here runs Monkey? Cool. So, who here runs Monkey with Server app? Cool. So, if you are looking for a server for Monkey, it's probably Nginx or Apache or something. You want to do it with certificates, right, Sam? Yeah. So, I wrote a server called Squirrel. It's awesome because it does that, and you don't have to worry about configuration. You say Squirrel serve a path to a folder for your repo, and you say the domain that you're going to use. Obviously, this has to be public. And then it supports basic auth, which Monkey supports. So you put some sort of password, and it'll dump back a token that you can then put in your Monkey configuration. Yeah. And then my final one, my favorite one, is this is how I use Let's Encrypt in Squirrel. And this is how you can use Let's Encrypt if you write Go. So this is a very simple hello world. The first line is create a router. Second line, I say on the main path, say hello MacDevOps17. And then this final line will create an HTTP server, bind to port 443, And if you go to MacDevOpsYVR17, it'll automatically fetch the certificate when you go there. And it'll serve that. So the first time somebody connects, it'll fetch the certificate. So yeah, there's many ways to use it, all written in Go somehow. Let's go and encrypt stuff. That's it.
Questions? You guys know about Monkey? Okay. Walk forward. Why are you making me walk?
Oh, there are questions. Okay, go.
I'm lazy.
Okay. So just so I caught it, you have to, in order to use Let's Encrypt, you have to have port 80 open, and you also have to have 443 open?
So you choose.
Okay.
There's 3 methods to obtain certificates. The first one is on port 80, the second one is port 43, and the third one is using one of the DNS providers that support it. So if you are using the DNS provider, you don't have to open any ports. That domain has to be reachable, though, somehow.
Thank you.